Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the most haunting and beautiful mysteries in all of science: black holes. These silent giants are born from the deaths of massive stars, blaze as quasars in the dawn of galaxies, and whisper to us about the deep architecture of the universe itself. But they also mark a strange boundary, a place where our measurements fail, where light fades, and where space and time fold into silence. Before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly enjoy these quiet explorations through science. And if you're still awake later, leave a comment to tell me where in the world you're listening from and what time it is for you right now. I always find it comforting to imagine all of us scattered across the planet, each in our own small corner of the night, connected by the same curiosity. Now, wherever you are, let the lights dim a little. Maybe you've settled under a blanket or you're lying back with your headphones on. Perhaps you can hear the low hum of your surroundings or the quiet rhythm of your own breath. That's perfect. You don't need to concentrate. Just let your thoughts drift, like dust floating in a beam of starlight. Tonight, we'll wander gently from the birth of stars to the strange depths where light itself disappears. We'll meet neutron stars that spin like cosmic lighthouses, and we'll follow astronomers who chase invisible objects through the night sky. We'll listen to the soft hum of galaxies and touch the edges of things our minds can barely imagine. So take a deep breath. Let your shoulders rest and your mind loosen its grip on the day. We're not in a hurry. The universe has been unfolding for billions of years. It won't mind waiting a little while longer for us. Now, feel the weight of the earth beneath you, a quiet reminder of gravity's constant embrace. That same invisible pull, the one that keeps you close to the ground, is the very force that shapes stars, bends light, and sculpts the deepest shadows in the cosmos. Tonight, we'll follow that pull wherever it leads. Let's begin. Far from our world, deep in the quiet of interstellar space, immense clouds of gas drift and shimmer, like curtains of light stretched across eternity. These are stellar nurseries, places where stars are born. Some of them, shaped by fierce winds from older, dying suns, rise like enormous towers against the darkness. Astronomers call them pillars, but when you see them through the eyes of the Hubble telescope, they look more like castles sculpted from smoke. Within those vast columns, gravity begins its patient work. Tiny knots of gas grow heavier, pulling in more of the cloud around them. Pressure builds, heat rises, and after thousands of centuries, a spark of nuclear fire ignites. A star is born, not with a bang, but with a gentle, steady light that will shine for millions or even billions of years. It's hard to imagine that something so immense can come from such a slow, quiet process. Yet that is how the universe builds its brilliance, grain by grain, atom by atom, in silence. But there's a secret hidden in this creation story. These clouds exist because other stars have already died. Massive suns, long gone, have scattered their ashes across space, feeding the next generation. Every shining new star carries the memory of those that came before it. Birth and death are not opposites in the universe. They're two halves of the same cosmic breath. And yet, for the most massive stars, that breath will end in catastrophe. When a giant star runs out of its fuel, hydrogen, then helium, and finally the heavier elements forged in its core, it can no longer resist the inward pull of gravity. The light dims, the outer layers begin to collapse, and in a single moment, the balance of forces breaks. The star's heart caves in on itself, and a supernova is born. If you could see it from afar, you'd witness one of the most dramatic events in nature. A single star outshining an entire galaxy for a brief time. The shockwaves tear through the surrounding space, sculpting new shapes in the nearby gas, pillars, towers and arcs that stretch for light years. The same winds that destroy also create, sweeping material together, sowing the seeds of future stars. Astronomers have watched this dance countless times, though the scale is almost impossible to grasp. The debris from a single supernova can travel billions of kilometers per hour, carrying with it the elements that will someday become planets, oceans, or even living beings. Iron from a star's heart may one day pulse in your own bloodstream. Carbon from a stellar core might rest in the structure of your cells. The universe doesn't waste its light. It reuses it endlessly, reshaping it into new forms. But not all of a dying star escapes into beauty. At the very centre of the explosion, something dense remains, a heart so heavy that atoms themselves cannot survive its pressure. This remnant becomes a neutron star, an object with the mass of our sun squeezed into a sphere only about 10 kilometers wide. Imagine a city the size of Manhattan, but weighing as much as 300,000 Earths. A teaspoon of that matter would outweigh mountains. Its surface is smooth and metallic, its gravity so fierce that even light bends as it escapes. These objects are the quiet survivors of chaos. They spin rapidly, sometimes hundreds of times a second, sending out beams of radio light like the beam from a distant lighthouse. On Earth, astronomers once detected those pulses and thought, for a brief moment, they might be signals from another civilization. They called them LGM, short for little green men, but it turned out to be something far more astonishing. A star's final heartbeat, repeating across the void. The Crab Nebula, one of the most famous remnants of a supernova, still carries such a heartbeat. Deep inside its expanding shell of gas, a tiny neutron star spins relentlessly, its radiation carving delicate rings in the mist around it. Through the Hubble telescope, it looks almost alive, ripples of blue and violet light moving outward like waves in a silent sea. For astronomers, this is a window into both life and death. The same supernova that destroyed a star also created the heavy elements that make planets possible. The same explosion that left behind a corpse of pure gravity also lit up the sky with beauty for centuries. If you close your eyes for a moment, you might imagine those colossal clouds, light drifting like slow smoke, the echo of an explosion still whispering through the gas. Somewhere in that vast silence, new stars are already forming, unaware of the story that birthed them. And in time, they too will blaze, fade, and fall. The universe is not in a hurry. Every birth carries the memory of its ending, and every death leaves behind the seeds of light. Somewhere within that cycle, gravity waits. Quiet, patient, and unstoppable. And it's gravity, that gentle but relentless sculptor, that will guide us deeper towards something stranger still, places where even light cannot find its way home. When a star collapses, the story of gravity becomes intimate. Its violence no longer spreads across light years. It folds inward, pressing matter into an impossible form. At the centre of the explosion, where temperatures climb higher than in the core of any living sun, atomic structure itself begins to fail. Electrons, those light particles that once danced around atomic hearts, are forced into the nuclei they once orbited. Protons and electrons merge into neutrons, and the space between them vanishes. What remains is something unlike anything we have ever touched. A sphere no wider than a small city, yet containing the mass of our entire sun. A teaspoon of its substance would weigh more than the Himalayas. Astronomers call it a neutron star, but the name barely captures the strangeness of it. It is, in a sense, the most perfect sphere in the universe. Smooth, hard, and so dense that light bends as it slides over its surface. Its gravity is immense. If you could somehow stand upon it, which you cannot, you would weigh 1 billion times more than you do now. A step would be impossible. Even a grain of dust falling onto its surface would release more energy than an atomic bomb. And yet these tiny stars spin serenely in the dark, relics of once radiant giants that burned all their fuel and collapsed into silence. To understand them, imagine the last instant of a dying sun. Its outer layers are hurled outward in a storm of light and gas, while the core implodes. For a brief heartbeat, the collapsing matter rebounds, creating the shock wave that we see as a supernova. Then the shock fades, leaving behind a compact remnant, a cosmic ember, glowing faintly in the X-ray and radio light. The death throes of one star and the birth of something entirely new. In the 1930s, physicists first proposed the existence of these compact remnants, but for decades they were theoretical ghosts, too small to see, too strange to believe. That changed in the 1960s, when a young graduate student named Jocelyn Bell was examining radio recordings from the sky. Among the noise, she found a repeating pulse, a rhythm so steady it was almost mechanical. Every fraction of a second, a burst of radio energy flickered through her instruments. At first, she and her team hesitated. Could it be a malfunction? Could it perhaps be something alive? For a few months, they labelled it with quiet humour, LGM, for Little Green Men, but the pattern was soon found in other parts of the sky, all pointing to natural, though no less wondrous, origins. These were pulsars, rapidly rotating neutron stars, their magnetic field sweeping radio waves through space like the beam of a cosmic lighthouse. Today we know of thousands. Some spin once every few seconds, others hundreds of times in the blink of an eye. They are the universe's clocks, keeping time more precisely than any device humanity has ever built. If one were placed on your desk, a harmless miniature if such a thing could exist, it would tick with a rhythm no heartbeat could match. But their true beauty lies not in their precision, but in what they represent, the persistence of order in the ruins of chaos. One of the most striking examples lies in the heart of the Crab Nebula. Long ago, in the year 1054, observers across the world saw a new star bloom in the sky. For weeks it shone brighter than Venus, visible even in daylight. It was a supernova, the death of a massive star 6,000 light-years away. Today its expanding remains form a delicate cloud of colour, photographed endlessly by space telescopes. At its centre lies the Crab Pulsar, spinning 30 times every second, surrounded by rippling rings of light that shimmer outward through the mist. Through the eye of Hubble you can almost sense its motion. Filaments twist like threads of silk, glowing in shades of blue and gold. It's easy to imagine it breathing. An illusion, of course, but a comforting one. The light from that explosion began its journey long before any human civilization existed, and it reaches us now as a faint echo of creation and destruction intertwined. Neutron stars challenge our sense of proportion. They remind us that density, mass and distance are not abstractions but scales of reality. If Earth could somehow be compressed to the same density, it would shrink to the size of a small marble. Inside such matter, the concept of an atom ceases to apply. What we think of as solid is mostly empty space, the gap between particles. Remove that emptiness, and the familiar world collapses into a single, incomprehensible point of weight. For scientists, studying these objects is like peering into a laboratory built by the universe itself. In their interiors, forces clash that we cannot replicate. Gravity, magnetism and quantum pressure balanced on the edge of collapse. They are in a way the last possible stop before matter disappears entirely into a black hole. One more ounce of mass, and the neutron star would not survive its own gravity. It would continue falling inward until it vanished from view, leaving behind only a shadow where space itself has curved shut. And yet, despite their proximity to oblivion, neutron stars endure. Some are born as pairs, orbiting each other in a dance so close that, from afar, they seem to blur into one. As they circle, They send out gentle ripples through the fabric of space-time. Gravitational waves, the faint shiver of the cosmos itself responding to motion. When they finally merge, they release bursts of energy bright enough to be seen across galaxies. From such collisions, heavy elements like gold and platinum are born, scattered through interstellar clouds to become part of new worlds. The ring on your finger, the circuits in your phone, the trace metals in your blood, all might have been forged in the brief blazing union of two city-sized stars. In this way, even destruction creates beauty. The universe recycles its extremes, turning death into possibility. It's humbling to think that these invisible remnants, no larger than a city, have shaped the chemistry of life and the architecture of worlds. We can't see them directly, but we can sense their presence through the faint flicker of radio pulses or the soft shimmer of their remnants in deep space photographs. They are reminders that even in the silence after catastrophe, something orderly, even gentle, can remain. If you imagine yourself drifting near one, far enough to be safe yet close enough to see, you would witness a star that no longer shines but still radiates power. Its surface glows faintly blue, its magnetic field stretching thousands of kilometers into space, guiding streams of particles like invisible ribbons. Every rotation sends out a flash that crosses your line of sight. Blink, 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 a rhythm older than any song. As you float in that imaginary darkness, the pulse slows to a heartbeat, the light softens, and the vast nebula around it fades into shadow. The silence feels complete, but it is not empty. It is the quiet of something still working, still enduring, long after the fire has gone. That quiet persistence, the refusal of matter to vanish, the calm that follows catastrophe, is gravity's gentlest gift. From here, the path leads further inward, toward places where even that quiet will fail, where gravity no longer balances but devours. Beyond neutron stars lie black holes, the final secret, where space folds into itself and time loses its direction. There is a point in the story of a dying star where gravity stops negotiating. Until that moment, the forces inside the star struggle to hold a fragile balance. Pressure pushing outward, gravity pulling inward. But when the nuclear fires at its core finally burn through their fuel, nothing remains to resist collapse. The star's outer layers are flung away in a last burst of brilliance, while the core itself begins its slow, unstoppable fall inward. For some stars, the collapse halts in the strange piece of a neutron star. For others, heavier still, 3 times the mass of our sun or more, there is no escape. Gravity wins. It crushes everything into a single, infinitely small point, and the star ceases to exist in any form we understand. The collapse does not simply make a smaller star. It makes a hole in space itself, a region where all known rules break. This is the birth of a black hole. To picture it, you might imagine space as a vast, flexible sheet. Place a marble on it, and the surface curves gently. Place a heavy ball, and it dips more deeply. Now imagine placing something so heavy that it tears the sheet entirely. That hole, the place where the curve becomes infinite, is what gravity does when it goes too far. Einstein's equations predicted such things in the early years of the 20th century, but even he dismissed them. The idea that a star could collapse into nothingness seemed, as he once wrote, too absurd. Space and time, he believed, could bend, but surely they could not tear. Many of his peers agreed. For decades, scientists treated the notion as a mathematical curiosity, a trick of the equations, not a feature of the universe. Yet gravity had other plans. Over time, the evidence became impossible to ignore. The motions of stars near invisible companions, the strange X-ray flares in the depths of galaxies, the energetic jets stretching across space, all pointed toward the same unseen culprit. Whatever these objects were, they were so dense, so dark, that light itself could not escape them. The shrugging phrase became familiar. If it isn't a neutron star, what else could it be? A black hole is not an object in the usual sense. It has no surface, no solid boundary. Instead, it is defined by an invisible border called the event horizon. Cross that line, and escape becomes impossible, not because of frictional walls, but because every possible path curves inward. Even light, which moves at the fastest speed the universe allows, finds every route leading back toward the centre. If you could approach such a boundary safely, and this is purely imagination, you would see the world around you distort. Time itself would begin to slow. For you, a few minutes might pass. For a distant observer, it would appear as though you were freezing in place, moving ever more slowly as you neared the horizon. In truth, your clock would be running normally. It's the universe's clock that would seem to accelerate. At the edge of a black hole, time and space exchange roles. Falling inward becomes not just a direction in space, but a direction in time itself. Scientists often describe the event horizon as the point of no return, but that phrase only hints at its strangeness. It is less a wall than a horizon at sea, a place beyond which your vision ends, though the world continues beyond it. For the black hole, that unseen world is a realm we cannot measure or describe. The equations say that at the very centre lies a singularity, a place where density becomes infinite and the known laws of physics fail. Whether that's a literal point or simply a sign that our understanding stops working is still uncertain, and yet, even as it hides everything inside, a black hole is anything but invisible. Matter falling toward it forms a swirling disk of gas and dust, heated to extreme temperatures as it spirals inward. The friction and gravity together generate light 1,000,000 times brighter than a star. Seen through telescopes that capture X-rays or radio waves, these disks glow like cosmic whirlpools, blazing against the dark. If you could watch from afar, you'd see something hauntingly beautiful. The light from the far side of the disk bends around the black hole, so that you see its back as well as its front. The hole itself appears as a perfectly round shadow, an absence ringed by a halo of fire. That ring is not the black hole itself, but the last orbit where light can circle before falling in. It's as though the universe draws a thin, glowing outline around its own erasure. For astronomers, these cosmic silhouettes are more than symbols, they are measurements. By observing the size of that luminous ring and the speed of the gas swirling around it, scientists can estimate the mass of the hidden core. In the galaxy M87, 50 million light-years away, such observations revealed a monster 2 billion times heavier than our Sun. When the Event Horizon Telescope captured its first image, it was like finally seeing the outline of an idea that had existed only in equations and imagination for a century. The picture wasn't sharp, more a soft blur than a crisp photograph, but that was fitting. The cosmos seldom reveals itself in perfection. The image showed a dark circle surrounded by a hazy ring of orange light, each photon bent by gravity on its long path to our telescopes. That light had travelled for tens of millions of years before finding us, carrying with it the shape of something that devours light. It's tempting to think of black holes as destroyers, but that isn't quite right. They are also sculptors. Their gravity shapes the galaxies they inhabit, influencing how stars are born and where matter settles. Some astronomers call them the engines of galaxies, regulating their growth through jets of radiation that can extend thousands of light years. These jets, launched from the magnetic chaos around the hole, carry energy far beyond what the star that formed them could ever produce. In this way, black holes serve as both graveyards and guardians. They mark the end of a star's life, but their presence helps guide the evolution of entire galaxies. The same gravity that silences light also orchestrates creation on scales too vast for us to comprehend. And though we will never touch or see one directly, their influence surrounds us. even our own Milky Way hides such a heart, a supermassive black hole named Sagittarius A, lurking 26,000 light-years away. From Earth, we can't feel its pull individually. It is too distant, its gravity too diffuse. But every orbit of our galaxy, every motion of its stars quietly acknowledges its presence. To think of black holes is to think of boundaries, where knowledge ends, where observation stops, where time hesitates. But in those boundaries lies something profound, a reminder that the universe is both knowable and mysterious, precise yet poetic. What we cannot see still shapes what we are. If you imagine drifting near such a horizon, you might sense the silence before the fall, the stillness of light hesitating at the edge of eternity. Beyond that line, space folds inward, and time itself begins to curve. No sound, no signal, no thought can escape. Yet outside, far away, a distant telescope watches the faint ring of fire and measures its size, and in that quiet act of observation, humanity reaches just a little further into the dark. That is where gravity stops whispering and begins to sing. A low, endless note resonating through space, telling us that even in the absence of light, the universe continues to write its story. In the mid-1990s, long before we had photographed the shadow of a black hole, a mysterious signal appeared in the sky. It was a sudden flash of gamma radiation, one of the brightest kinds of energy in the universe, detected by the Compton Gamma Ray Observatory. The light had erupted from the direction of the constellation Scorpius, thousands of light-years away. To astronomers, it was a summons. Something extraordinary had happened there, something powerful enough to shake the entire spectrum of the sky. Around the world, telescopes turned their gaze toward that single patch of darkness. From the Caribbean to Hawaii, radio dishes listened. In the mountains of Chile, optical telescopes began to trace the light from nearby stars. For months, teams across 8 countries exchanged data, piecing together a puzzle that, at first, made little sense. The source was small, compact and bright, a flare followed by a strange rhythmic dimming. Some suspected it might be a neutron star, others thought of an exploding white dwarf. But slowly, a pattern emerged that ruled out every ordinary explanation. Among those watching the data was a young astronomer named Charles Balin. From his observatory in the high desert of Chile, he had been tracking a faint, ordinary-looking star that seemed to behave in a most unordinary way. Its brightness changed in a repeating cycle, as though something unseen were tugging at it. That hidden partner was pulling it into an orbit lasting about 2.5 days, swift, tight, and violent. The visible star looked distorted, stretched slightly toward an invisible point in space. Matter streamed away from its surface, forming a disk around the unseen companion. From that disk, jets of gas shot outward at speeds approaching the speed of light. They extended for billions of kilometers before fading into nothingness. Astronomers had seen jets like these from distant galaxies, where giant black holes lived, but never from a system so small, so close. The more data they gathered, the more the picture sharpened. The unseen companion was roughly 7 times heavier than our Sun, far too massive to be a neutron star. And it emitted no light of its own. The only thing that fit was a black hole. This system became known as Jurojavesic 5540, though many preferred a simpler name, the 1994 Scorpius outburst. Imagine the scene from Balin's telescope. Night after night, he and his team watched the star dim and brighten, the curve of its light tracing the invisible orbit. Every few hours, the companion vanished from view, hidden behind the star it devoured. Then it would reappear, the system's glow shifting ever so slightly toward blue as the gas sped toward us, then red as it receded. Signatures of motion that could be measured, like a heartbeat of gravity itself. From those rhythms came the numbers that revealed its nature. The orbit's shape told the astronomers the mass of the unseen object. The mass told them the truth. Nothing visible could survive such weight without collapsing. It had to be a black hole. The confirmation wasn't a photograph or a dramatic burst of light. It was a slow accumulation of careful evidence, built on patience and precision. Balin later described the experience with a quiet sense of wonder. "It's the strange objects that always tell you the most about the universe," he said. "If you want to understand gravity, don't look at apples falling to the ground. Look at what happens when gravity nearly breaks." He and his team often spoke of the system using a whimsical image from Alice in Wonderland. The black hole, they said, was like the Cheshire Cat, a creature that vanishes entirely, leaving only its smile behind. In their observations, the smile was the gravitational pull, the invisible force shaping everything around it while remaining unseen. You couldn't look directly at it, but you could see the effects everywhere. The distorted star, the flickering disk, the jets stretching across space. For 5 nights, Balin and his colleagues kept vigil at Cerro Tololo, recording the subtle variations of light. The mountain air was thin and cold. The telescopes hummed softly as they moved to follow the star's path across the sky. Between exposures, there was silence, the kind that only deep night can offer. A silence broken only by the faint tapping of instruments and the whisper of wind through the domes. By the end of the week, the numbers told a story no one could deny. The unseen object was roughly 7 times the mass of our Sun, compact enough that even light could not escape. They had found one of the clearest examples yet of a stellar black hole. There was no explosion to mark the discovery, no sudden revelation, just the quiet appearance of a pattern that made sense at last. What happens inside such an object, no one can truly say. The mathematics leads us inward to a point where space and time themselves seem to end. Scientists can map the gravity outside it, can model the behaviour of the swirling disk, but beyond the event horizon, all predictions break. It is, in every sense, a place where science meets silence. For Balin, that boundary was more than a problem, it was an invitation. When you come to the edge of what science can tell you, he once reflected, that's where philosophy begins to speak. To him, observing a black hole was not just about measurement, but about humility, the recognition that the universe still holds secrets far beyond human reach. The 1994 Scorpius discovery changed how we study these invisible giants. It proved that even without direct sight, we could identify a black hole through the way it bends light, tugs at a companion, and stirs its surroundings. It was one of the first times the evidence was so clear, so unambiguous, that the scientific world could point to it and say, there, that's what a black hole looks like in motion. In later years, more would be found. Systems where stars dance with darkness, feeding it steadily, glowing with the energy of their own undoing. Each one tells the same story in a different rhythm. They orbit, they flare, they fade, and through them, gravity shows us its quiet artistry. If you imagine yourself standing on that mountain beside the astronomers, the night would feel immense. The stars above would appear still, yet every one of them is in motion, rotating, orbiting, evolving. Somewhere within that sea of light, a single point flickers just a little differently. You would not see the black hole itself, but you might sense its presence in the pattern of its companion's glow, like a heartbeat hidden beneath the surface of the sky. To discover something invisible requires both instruments and imagination. It requires a kind of faith, not blind belief, but the confidence that nature's patterns will reveal themselves if you listen closely enough. The astronomers who watched Scorpius in those months did just that. Through numbers, through careful watching, they glimpsed a smile left behind by gravity itself, and in that smile the quiet triumph of understanding. The discovery was not the end of the story, but the beginning of a deeper question. If black holes can be found among the stars of our own galaxy, what role do they play in shaping the vast cities of galaxies themselves? Somewhere beyond the reach of any single telescope, much larger beasts are waiting. Black holes, millions or billions of times heavier, anchoring the hearts of galaxies. As the Scorpio system faded back into silence, those distant giants began to call to us next. At the quiet heart of a distant galaxy called Messier 87, a storm has been raging for millions of years. From that storm rises a thin beam of light and particles, so vast that it stretches thousands of light years into space. It is a cosmic jet, a narrow river of energy launched from the core of a galaxy 50 million light years away. Through the telescopes that watch it, the jet seems motionless, but in truth it moves close to the speed of light. It is powered by something that emits no light of its own, a supermassive black hole. For decades, astronomers had suspected that black holes this large must exist. The idea was simple, but staggering. If a single star could collapse into a black hole with a mass a few times that of the Sun, then the same process, scaled up over billions of years, could produce something millions or even billions of times larger. These giants would live not in solitude, but at the centres of galaxies, shaping everything around them. They would feed on clouds of gas and on unlucky stars that ventured too close, releasing energy as they swallowed them, energy so intense that entire galaxies could see it. The centre of M87 is one of those places. When astronomers began to study it more closely, they found clouds of gas spinning around an invisible mass. The gas moved at astonishing speeds, hundreds of kilometres every second, too fast to be held by any visible object. Only a gravitational monster could explain it, one weighing more than 2 billion suns. And so, by watching what it moved, astronomers began to outline the unseen. It's strange to think of a black hole as something that can give light to the universe, yet that is exactly what it does. As matter falls toward it, it doesn't disappear quietly. Before it crosses the event horizon, it is whipped into a frenzy, heated to temperatures that make atoms tear apart. The gas glows in X-rays, ultraviolet and radio waves, creating a halo of light that can outshine entire galaxies. That radiant halo, spiralling faster than anything else in nature, is what astronomers call an accretion disk, a bright whirlpool around darkness. In 2019, the world saw that whirlpool for the first time. The Event Horizon Telescope, a network of radio dishes spread across the Earth, captured the faint light coming from the gas around M87's core. The image that emerged was simple but profound, a dark circle surrounded by a glowing ring of orange light. It was the first direct evidence of a black hole's shadow, drawn not with pen or paint, but with the bending of light itself. When you look at that image, blurred and imperfect as it is, you're seeing not just the edge of a black hole, but a triumph of patience and imagination. The light that formed it began its journey before humans had even learned to walk upright. It travelled for 50 million years, crossed the depths of intergalactic space, bent around gravity, and arrived here to end its story on the screens of a few small observatories on Earth. There is a quiet poetry in that. The universe, through its most destructive forces, becomes an artist. The ring of fire that outlines the black hole is not a border but a mirror. It shows us how space itself behaves when stretched to its limits. The dark centre is not truly an absence. It's a region where all paths lead inward, a place that refuses to let light finish its journey. To explain the scale of M87's black hole is to speak in metaphors, because the numbers themselves lose meaning. Its mass is 2 billion times greater than that of the Sun, and yet all of that is compressed into a sphere smaller than our solar system. The pull of its gravity is so immense that time runs slower near it, stretching seconds into hours for anyone who could hover nearby. And still, its influence extends far beyond its horizon. The energy it releases from its feeding disk and its twin jets can sculpt the gas of the entire galaxy, deciding where new stars will form and where they will not. In this way, black holes are not just endings, they are regulators, the engines that maintain balance in the cosmic ecosystem. If they feed too greedily, their jets blow away the gas that might have formed new stars, leaving the galaxy quiet and old. If they feed more gently, the gas remains, and new suns can still be born. Each galaxy's life depends in part on how its central black hole behaves, an unlikely partnership between destruction and creation. Imagine, for a moment, standing far outside M87, watching its jet unfold across the darkness. It would look like a thread of fire extending farther than imagination can follow. That light began near the event horizon, twisted by magnetic fields and gravity until it was shot outward. It might travel for millions of years before fading, lighting up regions of space that would otherwise remain dark. Each particle in that jet carries a fragment of the black hole's energy, like sparks from a cosmic forge. The more astronomers study these supermassive black holes, the more they realize how central they are to the story of galaxies. Every large galaxy we've observed seems to have one at its heart, and their sizes appear to grow in step with the galaxies themselves. It's as if the fates of stars and black holes are intertwined, each one shaping the other over billions of years. Some researchers now speak of galaxies not as collections of stars orbiting in space, but as vast ecosystems organised around a single gravitational seed. And though these giants are unimaginably distant, their echoes reach us. When their disks flare, when their jets flicker, those changes ripple across time and space until faint waves of radio light brush the antennas of telescopes on Earth. Scientists translate those signals into sound, and what we hear is not a roar but a hum, a deep, resonant note that vibrates through the air like the sound of a distant sea. It's easy to forget, listening to that hum, that the source is something so violent, so consuming. But that is the dual nature of the universe, calm and chaos sharing the same breath. The light that burns around a black hole may have once been part of a star, part of a planet, or part of a cloud of gas. Now it's transformed into energy that travels across the cosmos, carrying with it the trace of its encounter with gravity. When we gaze into that darkness, we're not only seeing the end of light's journey, but also witnessing the beginning of understanding. The black hole at the centre of M87 is more than a cosmic monster. It's a reminder that even in the deepest shadows there is order, symmetry, and beauty. The same equations that describe its pull also describe the way planets move and how you stay anchored to the ground. From the collapse of a star to the glow of a galaxy, gravity writes its story in every scale. It is the quiet architect, carving space into shapes we can barely imagine. The great engines of galaxies, these vast invisible hearts, are its masterpieces, proof that even in darkness the universe continues to create. If black holes are the silent hearts of galaxies today, then quasars are their younger, louder selves, their fiery adolescents. To look at a quasar is to look far back in time, into an era when the universe was still gathering itself together, when gravity was young and bold and everything burned brighter. A quasar begins with a supermassive black hole, but not one in quiet maturity like the heart of M87. These black holes were newborn giants, surrounded by oceans of gas and dust in the early universe. They fed voraciously. Each fragment of gas that spiraled inward released enormous energy before vanishing across the event horizon. The result was light so intense that one quasar could outshine thousands of galaxies combined. Through telescopes, they appear as faint, distant dots, yet their power would make every star in the Milky Way seem dim. Astronomers discovered quasars by accident. In the 1950s and 60s, they were scanning the skies with radio telescopes, searching for unusual sources of radiation. Some of those signals came from what looked like ordinary stars until their light was broken apart into colours and examined more carefully. The patterns were strange. Spectral lines shifted toward red, stretched by the expansion of the universe. These objects weren't nearby stars at all. They were galaxies so far away that their light had travelled billions of years to reach us. The farther they were, the faster they seemed to retreat. The redshift was not just a number. It was a message from the dawn of time. One of the first of these cosmic beacons was called 3C273, found in the constellation of Virgo. Its light had travelled for more than 2 billion years before reaching Earth, yet it still shone bright enough for small telescopes to see. Imagine that. Something born when life on our planet was still microscopic, sending us its story across half the age of the universe. The numbers themselves fade before the idea's beauty. To describe what a quasar really is, we can use an image rather than an equation. Picture a whirlpool in a dark ocean spinning so fast that it glows. Streams of matter fall inward, colliding, compressing, heating. As they spin closer to the centre, the gas reaches millions of degrees. The outer edges shine in ultraviolet, the inner regions in X-rays. Above and below this disk, magnetic fields twist and launch jets of particles at near light speed, piercing the surrounding space like cosmic searchlights. These jets extend for thousands of light years, their paths traced by glowing filaments of gas. Each quasar is both a wound and a lantern, a reminder that even destruction can give off light. In those early times, the universe was denser, and galaxies were still forming from primordial clouds. Black holes grew quickly because there was so much to consume. Each feeding frenzy illuminated the surrounding cosmos, turning darkness into radiance. The light from these quasars became our first signposts of structure, points scattered through the night sky that marked where the first galaxies were gathering. It's strange to think that as the universe ages, it grows dimmer. The early cosmos was full of fierce brightness. Young stars, wild black holes, restless matter. Today, things move slower. Most galaxies have settled into quiet routines, their central black holes sleeping, waking only occasionally to feed. But when we look back through the lens of time, we still see that younger universe, flickering like an ember that refuses to fade. Astronomers often describe quasars as lighthouses, and the metaphor fits perfectly. Each one is a message from a time when galaxies were learning to build themselves. By studying their light, scientists can trace how the first heavy elements were forged, how radiation shaped cosmic gas into filaments, and how supermassive black holes grew in step with the galaxies they anchored. When the light of a quasar passes through space, it encounters clouds of gas and dust between galaxies. Those clouds absorb certain wavelengths of light, leaving fingerprints, tiny dark marks, in the quasar's spectrum. By examining those patterns, astronomers can map the invisible matter between galaxies, reading the structure of the universe like a palimpsest, an ancient manuscript written and rewritten over time. Each quasar becomes not only a source of light, but a probe that reveals everything it has passed through on its long journey. And what a journey it is. The photons we detect from the farthest quasars began their voyage when the universe was less than a tenth of its current age. Back then, there were no humans, no Earth, not even a sun. Only the raw materials that would one day become all of these. Those particles of light have been travelling ever since, crossing expanding space, stretched thinner and redder by its growth, until they reached our small blue world. When we capture them with our telescopes, we're not just observing the past, we're touching it. For many scientists, the study of quasars carries a special kind of awe. They're too distant for us to ever visit, too immense to imagine standing near, and yet they connect directly to our own story. Without the heavy elements forged in the turbulent hearts of those early galaxies, carbon, oxygen, iron, planets like ours could never have formed. Every molecule in your body, Every atom in your blood was once part of a chain of events ignited by such cosmic fires. The night sky is not above us, it is within us, woven into our very structure. There is also something deeply human in how we find meaning in those distant lights. We give them names, catalogue numbers, coordinates, but beyond all that, they serve as symbols of endurance. Long after they stop shining, their light continues its journey, carrying the memory of their existence across billions of years. In a way, each quasar is an echo of time's persistence, proof that what happens once in the universe never truly disappears. If you close your eyes and imagine one, you might see not a violent furnace, but a slow, turning glow, a circle of light breathing in and out, steady as the tide. Around it, invisible forces pull and twist, yet the pattern remains elegant. To gaze upon that is to see the universe at its most exuberant, still young, still creating, still unsure of its limits. And as we look deeper into space, we keep finding more of them, fainter, older, farther away, each one a window into the beginning of everything. The farther we look, the younger the universe becomes, until the light fades into a fog of cosmic dawn. Beyond that, even quasars cannot reach us. But their light has done enough. It has shown us where the galaxies first gathered, where gravity first began to write its grand architecture. In their brilliance, we see the universe growing up, wild, radiant, and alive. And in their fading, we see ourselves, small sparks of consciousness in a quieter age, still looking back, still listening to that ancient light whispering across the dark. By now, you might imagine that we've come to know the universe well, that by tracing the light of quasars and mapping the glow of galaxies, we've drawn the full outline of creation. Yet when astronomers added up all the stars, gas, dust, and radiant energy they could observe, the total came to something shocking. The visible universe, the one we can see, accounts for only a tiny fraction of what exists. Most of it is invisible, matter that emits no light, reflects no glow, and cannot be touched or seen. It is known simply as dark matter. The phrase sounds mysterious, even poetic, but it describes something very real. The first hints came almost a century ago, when scientists studied how galaxies move. They expected the outer stars of a spiral galaxy to rotate more slowly than those near its centre, much as the outer planets in our solar system circle the sun at gentler speeds. But when the data came in, it told a different story. The outer stars were moving too fast, as if held by a gravity greater than the visible mass could provide. The galaxies should have been flying apart, yet they held together. Something unseen was anchoring them. Astronomers checked their calculations again and again. The pattern repeated everywhere they looked, in the graceful whirl of spiral galaxies, in the chaotic dance of galaxy clusters, even in the way cosmic gas moved through intergalactic space. It was as though an invisible skeleton ran through the universe, providing structure and balance. The term dark matter became the simplest way to describe what they couldn't see, but could feel through gravity's pull. To picture it, imagine a vast mobile hanging in space, a sculpture made of light. The stars and galaxies are the bright ornaments, but the wires that hold everything together are hidden. Dark matter is those wires, invisible but essential, shaping the dance of the cosmos. What is it made of? That remains one of the deepest open questions in modern science. There are dozens of possibilities. Some think dark matter is made of tiny particles that rarely interact with ordinary atoms. Others suspect it could be something even stranger, undiscovered types of fields that fill space with subtle weight. And a few still wonder whether our understanding of gravity itself might need revision. Whatever the answer, dark matter outweighs normal matter by more than 5 to 1. In other words, for every bit of matter we can see, 5 more exist in shadow. We know it's there not because we can observe it directly, but because we can see its influence. Light from distant galaxies bends as it passes through regions where dark matter is concentrated, a phenomenon known as gravitational lensing. Sometimes the light stretches into arcs or rings, like the distorted reflection of a candle in a curved mirror. By mapping these distortions, astronomers can trace where the invisible mass lies, turning gravitational whispers into a kind of topographic map of the unseen universe. One of the most haunting realizations in all of astronomy is that the cosmos we see, the stars, the galaxies, the glowing nebulae, is only the frosting on a much larger cake. Beneath it lies a deep framework, unseen but omnipresent. It extends like a web across billions of light years, with galaxies strung along its filaments like dewdrops on a spider's thread. This structure is sometimes called the cosmic web, and dark matter is its scaffolding. You might wonder how something invisible can have such an enormous role. It helps to think of it not as emptiness, but as potential. Where dark matter collects, its gravity draws in gas, forming galaxies and stars. Where it is sparse, space remains mostly void. The visible universe, in all its beauty, is simply light tracing the contours of this hidden architecture. There's a soft irony in this. The brightest things in the universe owe their existence to something that never shines. Every star, every planet, even our own galaxy, was shaped by the quiet guidance of this unseen material. Without dark matter, galaxies would not have gathered. The night sky would be far emptier, perhaps even silent. To understand the scale, imagine holding a single handful of space. It seems empty, but within that volume there may be hundreds of invisible particles of dark matter passing through. They move silently, unaffected by the light that defines our senses. You cannot feel them, yet their presence holds galaxies together and dictates the cosmic architecture on which everything we know depends. In this way, dark matter is both humbling and strangely comforting. It reminds us that what we perceive is not all that exists. The universe is fuller, richer, and far more complex than our eyes can reveal. When you look up at the night sky and see its glittering expanse, know that there is far more in that darkness than there is in the light. There's also something poetic in the symmetry between black holes and dark matter. Both are defined by invisibility, by what they hide rather than what they show. A black hole conceals a single point of infinite collapse, a place where time and space end. Dark matter, by contrast, is not a place but a presence, a kind of soft gravity that fills space without boundary. One is concentrated silence, the other diffuse shadow. Together they form the yin and yang of the cosmos, one swallowing light, the other guiding it. For scientists, studying dark matter is like trying to map a landscape by listening to the wind. Every clue comes indirectly. The motion of stars, the bending of light, the ripples in the afterglow of the Big Bang. Bit by bit, the picture becomes clearer. Massive galaxy clusters act as magnifying glasses, their gravity bending light into patterns that reveal how dark matter is distributed. Computer simulations show vast web-like filaments growing over cosmic time, forming the backbone of the universe we inhabit. And still, even after decades of research, no one has ever touched a particle of dark matter or seen its direct trace in a detector. It remains an elegant mystery, half theory, half observation and all wonder. But perhaps that's fitting. The universe, after all, has never owed us its full disclosure. Some of its beauty lies precisely in what it chooses to hide. If you imagine the cosmos as a great piece of music, dark matter would be the bass line, steady, deep, and almost inaudible, yet shaping the rhythm of everything above it. The stars are the melody, the black holes the dramatic percussion, but without that unseen foundation, the song would fall apart. As you lie beneath the night sky, think of the darkness not as emptiness but as presence, as the quiet scaffolding on which every beam of light rests. The stars shimmer and fade, galaxies drift and collide, but the invisible web remains, holding them gently in place, It is the universe's most patient creation, the architecture that endures when light itself has gone. If you could step outside the Milky Way and drift far enough into the cosmic night, the universe would begin to take on a strange, delicate shape. At first, you would see only scattered galaxies, bright islands floating alone. But as you move farther back, through deeper distances and older light, patterns would start to appear. Clusters would gather like constellations of constellations, linked by invisible bridges. In the largest view, the universe would resemble a vast web, glowing faintly at its intersections, empty in between. Astronomers call this the cosmic web. It is the grand structure that binds the visible universe, woven over billions of years by the slow pull of gravity. The luminous threads you would see, clusters of galaxies, arcs of light stretching for hundreds of millions of light years, trace the densest parts of this invisible framework. The spaces between them are enormous voids, regions where matter is so scarce that entire galaxies could pass through without ever meeting another. The web's foundation is dark matter. It provides the gravity that draws ordinary matter into its filaments, guiding the formation of galaxies along its strands. Computer simulations show it as a mist of invisible particles clustering together, their gravity deepening the valleys where gas falls and stars ignite. The result is a universe that, though chaotic in detail, is remarkably ordered in its design. To imagine it in human terms, think of rain trickling down the slopes of a mountain range. The paths the water follows are determined not by the water itself, but by the unseen shape of the land beneath it. In the same way, the flow of light and matter across the cosmos follows the hidden contours of dark matter. The galaxies we see are like rivers, tracing the ridges and valleys of an invisible geography. This hidden architecture is not static. It is alive with motion, though on timescales far beyond our comprehension. Over billions of years, filaments stretch and twist as gravity pulls on them, slowly collapsing matter into ever denser knots when new galaxies form. The cosmic web grows more intricate, while the spaces between expand with the universe's own stretching. The overall picture is one of quiet evolution, a vast lacework of light and shadow that grows fainter but more complex with time. We can't see dark matter directly, but we can see how it bends the light from distant galaxies, distorting their shapes as if the fabric of space were made of glass. This phenomenon, known as gravitational lensing, allows astronomers to map the unseen mass. When light from a quasar or galaxy cluster passes near a massive region of dark matter, its path curves, sometimes splitting into multiple images, or forming perfect rings of light called Einstein rings. These natural lenses act like magnifying glasses, revealing details far beyond the reach of our telescopes. By studying these distortions, scientists can reconstruct the distribution of dark matter across the sky, turning the invisible into a ghostly portrait of gravity's reach. It is as if the universe sketches its own bones in light. The image that emerges shows a delicate balance, dense nodes connected by thinner filaments stretching in all directions. Even the vast emptiness between the filaments, the cosmic voids, plays a role, providing the counterweight that allows structure to grow. The beauty of this discovery lies in its irony. We built telescopes to seek light, yet it is through darkness that the universe's true form is revealed. In the dance between matter and emptiness, gravity creates design, and in that design we find harmony. Every galaxy, every cluster, every shimmer of starlight is simply a trace of this hidden architecture. It is easy to think of dark matter as something alien, but in a way it is familiar. It plays the same role in the universe that the subconscious plays in the human mind. Silent, unseen, yet shaping everything that follows. The stars are our thoughts, brilliant and fleeting. Dark matter is the quiet intention beneath them. Without it, the structure would collapse into chaos. The cosmic web also connects us in unexpected ways. The heavy elements that form planets, oceans and bodies come from stars that formed along these filaments. Those stars died, scattering their contents into space, where gravity recycled them into new generations. Every atom of carbon and oxygen on Earth was once part of that flow, guided by the same invisible scaffolding. The universe is not random. It has memory written into its very shape. If you could watch the web evolve, sped up across billions of years, it would look like the slow bloom of frost across a window pane. Filaments would stretch, connect, and thicken, glowing brighter where galaxies form, dimming where voids grow. The pattern would appear alive, spreading outward from tiny ripples that began in the first moments after the Big Bang. Those ripples, minute fluctuations in the density of the universe, served as seeds from which all later structure grew. From them came the clusters, the galaxies, the stars, and eventually us. It is humbling to realize that every familiar thing, from a grain of sand to the light of the sun, belongs to this larger geometry. The same gravity that makes you fall toward the ground also weaves galaxies into filaments. The laws of physics do not change with scale, they only deepen in complexity. The pull you feel when you drop a stone is a whisper of the same force that binds clusters of galaxies across 100 million light years. When we map the cosmic web, we are not just charting the shape of the universe, we are mapping our place in it. The Milky Way is one small pearl threaded on one strand among countless others. Around it lie neighbouring galaxies, small companions bound by gravity's invisible thread. Beyond them, other clusters shine faintly, linked in a structure so vast that our minds can only approximate its size. And yet, despite its enormity, this web has a softness to it. It is not rigid but fluid, always changing, always expanding. The filaments slowly drift apart as the universe accelerates in its expansion. Someday, in the far future, the most distant threads will slip beyond the horizon of what can be seen. The cosmic web will still exist, but much of it will no longer be visible to any observer, no matter how powerful their telescope. What remains will be a smaller, quieter universe, still structured but lonelier. When that time comes, billions upon billions of years from now, the story will continue, just at a slower pace. New stars will still form along the filaments that remain. New worlds may still rise and fall, guided by the same hidden geometry that shaped everything before. The universe may grow dimmer, but its pattern will persist, like the faint outline of a constellation remembered long after the stars have faded. So when you look up at the night sky and see the faint mist of the Milky Way stretching across the darkness, you are seeing just one thread in that vast tapestry. The stars above you are the surface of something far larger and older. A structure of light suspended within a structure of shadow. The universe is not a random scattering of stars. It is a living network, an intricate harmony between what shines and what stays unseen. And we, small as we are, belong perfectly within its design. High on a desert mountain, beneath the slow spin of the stars, a small group of astronomers waits for night to deepen. Their telescopes stand like sentinels under the cold sky, domes turning silently as computers hum and whisper. Inside, coffee cools in paper cups, and someone adjusts a focus knob with the care of a violinist tuning an old instrument. They're not here to watch the familiar stars, but to find the ones that are about to die. Supernova hunters, they call themselves. Their job is to search for sudden bursts of light that appear in distant galaxies, brief flares marking the death of massive stars or the collision of white dwarfs. These events happen at random, scattered across the sky, so the only way to catch one is to keep watching, night after night, like patient fishermen waiting for a shimmer on dark water. On most nights, the sky offers nothing new. Galaxies look the same as they did the night before, faint smudges of grey light against blackness. But every now and then, a single point brightens where none existed before. It might be faint at first, barely more than a whisper of extra light in a spiral arm of a galaxy. Yet within hours, it grows, swelling into brilliance. A supernova has arrived. When that happens, the observatory wakes up. Data streams begin to flow, telescopes pivot, voices sharpen with quiet excitement. On a monitor, the light curve begins to rise, a graceful arc that shows the explosion's growing power. The numbers might look dry, but to those who know what they mean, they tell a story of unimaginable violence. A dying star collapsing inward, rebounding and blasting its outer layers into space. For a few weeks, it will shine brighter than all the other stars in its galaxy combined. Then it will fade, leaving only expanding clouds of gas, the ashes of what was once a sun. To outsiders, this may seem like a strange kind of passion, staying awake through long, cold nights to watch a point of light brighten and vanish. But to astronomers, these moments are windows into cosmic creation. Each supernova releases heavy elements into space: iron, calcium, gold, carbon, the building blocks of planets and of life. Without them, Earth itself could not exist. The act of destruction becomes an act of creation. When they first started hunting supernovae systematically, in the late 20th century, astronomers used photographic plates, checking the same regions of sky again and again to look for changes. Now, digital detectors have made the search faster, but the feeling remains the same. The sudden appearance of a new light never loses its power to thrill. Some researchers have described the moment as a small form of time travel, witnessing the death of a star that occurred millions of years ago, its light only now reaching Earth. Sometimes, during quiet hours at the observatory, the scientists talk about what they're really looking for. It's not just explosions, it's meaning. In the long hours of waiting, there is a rhythm, a reminder that even the most stable-seeming heavens are always in motion. Stars are born, live and die in cycles that last far longer than any human life, yet by capturing their light, we get to take part in that story. There's a scene that repeats itself across observatories worldwide. A researcher leans back from the telescope console as the data finishes recording. It's late, perhaps 3 a.m, and the mountain is utterly still. On the monitor glows the image of a distant galaxy, with one bright point standing out like a candle flame. The observer notes the coordinates, marks the time, and whispers softly, "There it is." For a moment the lab is filled with quiet awe. In that flicker of light, millions of years of stellar history have come to an end. These discoveries are not just scientific, they are deeply human. Every measurement is an act of curiosity, a way of connecting ourselves to something larger. The thrill of finding a new supernova is not unlike the feeling of seeing sunrise after a sleepless night. It reminds us that change, though sometimes violent, is part of the universe's balance. The data gathered from supernovae has reshaped our understanding of the cosmos. By comparing their brightness and distance, astronomers have measured how fast the universe is expanding. In the late 1990s, 2 teams studying these stellar explosions made a startling discovery. The expansion of the universe is speeding up, not slowing down as once thought. This was the first evidence for what we now call dark energy, a mysterious force pushing space apart. It's fitting somehow that we learned this cosmic truth not from calm observation, but from the brilliant deaths of stars. Each flash of light recorded on those quiet mountain nights adds another note to the universe's symphony. Some of those explosions happen in spiral galaxies like our own, others in strange elliptical clouds billions of light years away. Some fade in days, others linger for months. The more we study them, the more we learn about how the universe recycles itself, how every atom of carbon in your breath and calcium in your bones once burned in the heart of a long-forgotten sun. Even when the supernova fades, the work doesn't end. Teams of researchers analyse its afterglow, studying the shockwaves that travel through surrounding space. They measure how quickly the expanding shell cools, how its composition changes over time. These details reveal what kind of star exploded and how its final moments unfolded. It's a detective story played out in light and silence, each clue helping us understand how matter transforms. And after all the excitement, when the lights in the observatory are turned down and the computers finish their quiet whirring, there's a moment of stillness. The astronomers step outside into the cold night. Overhead, the stars seem infinite, indifferent, yet strangely close. Somewhere in that vastness, another sun has just exploded, and its light is already on its way. They won't see it for millions of years, but they know it's coming, a future discovery already written in the sky. It's in those moments, when exhaustion blurs into wonder, that science feels closest to poetry. The hunters of exploding stars are not just measuring light, they're tracing the heartbeat of the universe itself. Each flash reminds us that endings are not really ends, just transformations waiting to happen. The light from those distant deaths will travel across the cosmos, pass through our atmosphere, and one night, land softly on a telescope's mirror. It will enter a darkened dome, strike a detector, and awaken a scientist's quiet joy. And somewhere far above, in the silent reach of space, the universe will continue its slow rhythm, stars igniting, burning, collapsing, each one a spark in the long conversation between creation and decay. Long before dawn, the observatory sits in silence. The mountain air is thin and cold, the sky stretched wide and perfect above it. Inside, the hum of machinery mingles with the quiet murmur of keyboards, a kind of artificial heartbeat echoing through the dome. The astronomers who have stayed awake through the night move softly, almost reverently, their voices low so as not to disturb the fragile balance between concentration and fatigue. On their screens, the universe appears not as a sky full of stars, but as streams of numbers and faint traces of light. These are the tools of their trade, photons that began their journey long before Earth even existed, arriving here one by one, collected by mirrors and lenses, then translated into data. Each point of light is a message from across time and space, a whisper from something unimaginably far away. When we look at the night sky, our eyes see beauty, patterns of stars, constellations, the soft smear of the Milky Way. But astronomers see something more abstract, more patient. For them, every colour of light holds meaning. A faint bluish hue might reveal a star's temperature. A subtle reddening might betray its age or distance. In a way, they don't just look at the sky, they read it. Spectroscopy, they call it. Though the word hardly captures the poetry behind it. It is the study of starlight spread into its colours, like sunlight refracted through a prism. Each pattern of lines within that rainbow tells a story. The presence of hydrogen, the breath of oxygen, the trace of iron or carbon. To those who know how to interpret it, every star becomes a sentence written in light. Every galaxy, a library. And yet, the process of reading it is anything but glamorous. It requires hours of careful exposure, calibrating instruments, recording data, correcting for dust and noise. Sometimes the telescope must follow a single star across the sky all night, gathering enough photons to form a clear signal. There are no instant revelations, only patience, the slow accumulation of truth. During those long nights, time itself feels elastic. Hours stretch and fold. A few seconds of starlight can take years of planning to capture and a lifetime to interpret. The astronomers measure, analyze, compare, and in doing so they reach across billions of years. A photon that left a distant galaxy before the first human drew breath now strikes a detector, becoming a point in a graph, a clue in a grand story. It's easy to imagine science as cold and precise, but in truth it has its own tenderness. The work demands humility. Astronomers can't change what they study. They can only wait for the universe to reveal itself, one photon at a time. They measure what they can, knowing most of reality remains hidden. And in that act of patience, there's a quiet grace, an acceptance that to understand the cosmos is to be small before it. Some of the researchers joke softly to stay awake. Someone makes tea, its steam curling like a miniature nebula in the lamplight. Another leans against a console, eyes closed for just a moment, listening to the hum of the dome turning above. In that sound, they hear something deeper, the rhythm of Earth itself spinning through space, carrying them along in its steady orbit. When dawn begins to touch the edge of the sky, the telescopes close their eyes, shutters sealing with mechanical precision. Outside, the horizon glows faintly pink. The astronomers step into the cold air, stretching stiff limbs, faces pale with exhaustion and quiet satisfaction. Behind them, the computers finish their calculations, storing the night's harvest of light. One of them looks up, squinting against the growing brightness. "We've been measuring ghosts," she says softly, half to herself. "Light that's older than the world." And she's right. Every observation is a message from the past. When we study the stars, we're not seeing them as they are now, but as they once were. Some may already have died, their last light still crossing the void. It's like listening to an echo from a mountain long after the voice that made it has gone silent. That understanding changes something in the way you see the world. It stretches your sense of time, reminding you that every moment we experience is layered with the remnants of everything that came before. The photons that warm your skin today might have been born in the heart of a star long vanished. The atoms that make you are forged in countless suns that lived and died long before humanity dreamed of the sky. When the astronomers later study the data, they'll transform those streams of light into meaning. A curve will reveal the speed of a distant galaxy. A faint line, the signature of an element unseen. With enough of these pieces, they can reconstruct the story of how the universe has evolved, how it expands, cools, and transforms. But alongside the calculations lies something quieter, the recognition that knowledge itself is a fragile bridge, built between what is measurable and what can only be felt. The great irony of studying light is that it teaches you about darkness. The more we learn about the cosmos, the more we see its vast unlit spaces, its hidden forces, dark matter, dark energy, things that can only be known through their effects. Even in our own understanding, darkness remains. What we don't know far outweighs what we do. But perhaps that's what makes the pursuit beautiful. To measure the invisible is to trust that the unseen still exists, that silence itself can be a form of communication. There's an old saying among astronomers, you never truly see the universe. You only see what it allows you to notice. The rest you must imagine. And imagination, guided by patience, is as vital as any telescope. It bridges the gap between numbers and wonder. Later, as the observatory quiets and the sun climbs higher, the night's data will be sent to labs across the world. Scientists will sift through it, adjusting models, testing theories. Most of what they find will be small, tiny refinements to what's already known. But sometimes, hidden in the margins of the ordinary, a new pattern appears, a spectral line that doesn't belong, a brightness that shouldn't be there. And with that discovery, a single human lifetime connects to the immense story of the universe. That is the true miracle of astronomy. Not that we can understand so much, but that the act of understanding brings us closer to humility, to measure light millions of years old, to record it faithfully, to interpret it with care. These are acts of reverence as much as reason. The cosmos doesn't reveal its secrets easily, yet it rewards those who listen with patience. In the end, every astronomer, every dreamer who looks at the night sky shares the same quiet realization. The light they chase is ancient, but the wonder it awakens is always new. And somewhere, in the faintest smudge on a screen, they sometimes catch a glimpse of themselves, not as observers apart from the universe, but as part of its unfolding story, written in the same light they seek to measure. There is a limit to how far understanding can reach, a horizon not of light, but of comprehension. Every science eventually finds it, the point where questions no longer yield to measurement, where knowledge begins to fade into wonder. For astronomy, that limit is the singularity, the hidden centre of a black hole, where the familiar laws of space and time dissolve. We often imagine the universe as vast and open, full of endless places to explore. Yet deep within certain corners of that openness lie regions that seem to erase meaning. At the heart of a black hole, matter is crushed into a point so small that it has no width, no volume, no inside or outside. The pull of gravity becomes infinite there, at least as far as our equations can tell. Distances vanish, time loses its direction, and what remains is something we can describe only in mathematics, never in experience. Scientists call it a singularity, but that word too feels fragile. It's a placeholder for something beyond description, a boundary between knowing and mystery. When we say singularity, we're not naming a thing, we're admitting the edge of understanding. If you could somehow approach that boundary, space itself would seem to stretch and fold. The light around you would curve inward until every direction pointed the same way, toward the centre. Time would slow, then freeze. From your perspective, nothing strange might happen. You would cross the event horizon in a quiet moment, unaware that the universe outside would never see you again. To an observer watching from far away, you would appear to hover at the edge, fading slowly, your image trapped just above the surface of the black hole. The mathematics that predicts this is elegant but unforgiving. Einstein's general relativity describes how gravity bends space and slows time, and within those equations, black holes are natural consequences. But when the equations are pushed too far, when matter becomes infinitely dense, they cease to give answers. They divide by zero, so to speak, producing infinities that make no physical sense. It's at this point that the two great pillars of modern science, relativity and quantum mechanics, begin to disagree. Relativity governs the vast, the smooth, the cosmic. Quantum theory governs the small, the uncertain, the flickering world of atoms and particles. Each works perfectly within its own realm, but at the singularity they clash. One predicts smooth curves, the other granular chaos. Neither can fully describe what happens when both gravity and quantum effects become extreme. This conflict is more than mathematical, it's philosophical. It reminds us that our knowledge, no matter how advanced, remains incomplete. Somewhere beyond that horizon lies a truth our tools cannot reach, and perhaps that is as it should be. The singularity is not a failure of science, but a mirror showing the limits of human reason and the beginning of imagination. To explain it in gentler terms, imagine that space is like a map. We can chart mountains, valleys, rivers, stars, but there are places where the map's lines converge into a blur, where no scale can capture what happens. The singularity is that place, the spot where the map folds back on itself and every direction leads inward. It is the end of navigation, and yet endings have their own beauty. The existence of singularities suggests that the universe is not entirely open to inspection, that it preserves a measure of mystery. Even as we learn more about black holes, their interiors remain silent, hidden behind the curtain of the event horizon. No signal can cross that border. No information, at least according to our current understanding, can escape. What falls in seems to vanish from the ledger of the universe. Stephen Hawking challenged that notion when he proposed that black holes might not be completely silent. He showed that quantum effects near the event horizon could create faint radiation, a slow whisper of energy escaping over unimaginable spans of time. In this way, a black hole might eventually evaporate, returning its energy to space. But even then, a puzzle remains. What happens to the information that once fell inside? Is it lost forever, or somehow encoded in the radiation that escapes? This is known as the information paradox, and it's one of the deepest questions in physics. Behind it lies something profoundly human, the belief that nothing in the universe truly disappears, that every story, every atom, every whisper of existence is recorded somewhere, even if we can't read it. Perhaps that's why this problem captivates not only scientists but dreamers, philosophers, and poets alike. It speaks to our instinct that meaning must endure. There are those who think the singularity may not be a literal point at all, but rather a veil, an area where our current understanding breaks down, hiding a new kind of physics waiting to be discovered. Perhaps space and time are not continuous, but woven from discrete threads, and the singularity is where those threads tangle too tightly for our equations to unravel. Or perhaps, beyond the horizon, space is reborn, a new universe budding from the collapse of an old one. Each black hole a seed of creation rather than destruction. We don't know, and maybe for now, we can't. The inside of a black hole is forever cut off from us, unreachable by light or signal. It exists as an idea, a mathematical dream. But ideas have power. They push us to the edge of what can be tested, to the frontier where science brushes against philosophy. In that sense, the singularity is not just an end, but a bridge, linking what we can measure to what we can only imagine. When you think of it this way, the black hole becomes more than an object. It becomes a symbol of humility. It reminds us that even in an age of satellites and telescopes and particle accelerators, there are still places we cannot reach, mysteries that remain untouched. Perhaps this is what gives science its soul, the willingness to approach the unknown, to ask questions even when we know there may be no answers. If the universe has an edge, it is not found at its outer boundary, but in the quiet limits of understanding. There, at the threshold of the singularity, knowledge gives way to awe, and equations give way to silence. It is the place where thought itself bows to something larger, where reason fades into reverence, and mystery becomes not a problem to solve, but a presence to accept. The singularity, then, is not only a feature of physics, it is a reflection of us, of our desire to know, our courage to admit we do not, and our grace in standing before the unknowable. Like the horizon between night and dawn, it marks not the end of light, but the beginning of something deeper, something we can feel even if we cannot see. Every life, every planet, every glimmer of starlight floats upon the same current, a river called time. It moves quietly without beginning or end, carrying galaxies, atoms, and memories downstream together. When we speak of time, we often imagine it as something we travel through, a sequence of moments like beads on a string. But in truth, it is the water itself. We're not outside of it, watching it pass. We're inside it, flowing with it, part of its motion. Long before there were clocks or calendars, the universe was already keeping time, not with hands that turned, but with change itself. The first seconds after the Big Bang mark the first rhythm, matter cooling, space expanding, light breaking free. In that primordial instant, the universe set its own tempo, and every event since has followed its beat. When we look deep into space, we're also looking backward in time. The light from a galaxy 10 billion years away began its journey when Earth had not yet formed, when the universe was only a fraction of its current age. Each photon we catch is a messenger from a younger cosmos, a tiny drop in this endless river, carrying with it the memory of how things once were. The night sky, then, is not a photograph. It is a living timeline. The farther we look, the farther upstream we see, and what we find there is astonishing. Out of quantum ripples, tiny fluctuations in the newborn universe, came the seeds of structure. The denser regions drew in more matter, growing into galaxies, while the emptier spaces stretched into vast voids. From chaos came pattern, from pattern, order, from order, life, all of it powered by time's steady current. That same current flows through us. The calcium in your bones was once forged in the heart of a dying star. The oxygen in your lungs was born from the nuclear fires of another. The carbon that carries your thoughts was woven in the explosions of supernova billions of years ago. When you breathe, you're breathing the dust of ancient suns. The atoms that make you are old beyond imagination, yet they keep finding new ways to arrange themselves, to live, to remember. Imagine time not as a straight line, but as a river winding through a valley, its waters constantly renewed though the flow is continuous. Each drop is different, yet the river remains the same. The moment you are living right now, this heartbeat, this breath, is both new and unimaginably ancient. It has flowed through the veins of the universe since the first light dawned. Physics tells us that time is not absolute. It bends and stretches depending on gravity and motion. A clock on a mountaintop ticks ever so slightly faster than one at sea level, because gravity is weaker there. Near a black hole, the difference becomes enormous. Time slows so much that, to a distant observer, a falling object seems frozen at the edge forever. This is not imagination. It is woven into the fabric of reality itself. But there is another kind of time, one not measured by clocks. It's the time we feel, the rhythm of living, of waiting, of remembering. The universe keeps both kinds, the mechanical and the emotional, side by side. The physicist measures intervals, the dreamer feels moments, and yet, in their own ways, both are true. When you think of it like this, every moment becomes sacred. The next breath you take has travelled across eons to reach you. It began as sunlight falling on an ancient sea, feeding plants that released oxygen into the air, which then joined the wind, which now enters your lungs. That breath connects you to everything, to stars, to oceans, to forgotten centuries. You are part of the same circulation, the same exchange that has been happening since the beginning. Sometimes when we talk about cosmic time, it feels overwhelming. Billions of years, billions of galaxies. But the scale doesn't make us smaller, it makes our belonging deeper. We are latecomers in the story, yes, but we are also the universe finally awake enough to tell its own tale. Every human thought, every question we ask, is time reflecting upon itself. There is a moment in the life of every star when its core begins to fuse carbon, oxygen, and heavier elements, changing forever the chemistry of its surroundings. That transformation echoes in us. The same carbon that burns in a star's heart now flows through our veins, carrying signals that make us dream. The same iron that once glowed inside a supernova now moves in the red of our blood. The universe does not simply surround us, it lives within us, continuing its experiment through our hands and voices. Seen this way, time is not an arrow shooting toward the future, but a great wheel, always turning, recycling its light and matter through endless forms. What was once a star becomes a planet. What was once dust becomes life. What was once a living breath becomes air again. Nothing truly vanishes. It only changes place within the current. Even memory follows this pattern. We think of remembering as something that happens inside us, but perhaps the universe remembers too. The light from ancient stars still travels outward, never truly lost. The ripples we make in time, a word spoken, a touch, a thought, might be small, but they are real. They move outward through the river, subtle but unbroken. Somewhere, in ways we cannot yet measure, existence keeps the trace of everything. When you stand beneath the stars and feel a strange calm, that may be the recognition of continuity, a quiet sense that you're not a separate being, but a brief shape taken by the river as it flows. You are never outside of it, and you never will be. Time is not passing by you. You are time passing, time feeling, time aware of itself for just a moment. There is comfort in that. It means that even as things change, as stars burn out, as galaxies drift apart, as lives begin and end, nothing is wasted. The atoms that make you now will go on, finding new homes, new forms, new rhythms. The river never stops, it only changes course. And somewhere in that endless movement, the universe pauses, just long enough to look back through you and see itself, before flowing onward again. When you look up at the night sky, the light you see is already old. Every star, every faint smudge of a galaxy is an echo from the past. The farther its light has travelled, the older that echo becomes. To gaze into space, then, is to gaze through time itself, as if the universe were holding up a vast mirror made of memory. In that mirror we glimpse the distant past, the first galaxies flickering to life, the afterglow of the Big Bang still faintly warming the cosmic background, the slow unfolding of everything that has ever been. What we call the present universe is really a chorus of many different ages, all singing together in light. The stars near us may be only hundreds of years away in time, their light practically new. Others, seen only as specks through the strongest telescopes, began shining when the universe was still young. This layering of time gives the cosmos a strange intimacy. It allows us to reach across distances we can never travel. When the light of a supernova appears suddenly in the sky, we are not witnessing a star die now, but long ago, perhaps when humanity was still learning to make fire. That light has been travelling toward us ever since, across the cold void, carrying its story without ever slowing, until it finally enters our eyes or a telescope's mirror and becomes a moment of discovery. Every observation is, in a sense, a time machine. The great observatories scattered across deserts and mountaintops are not just instruments of science, they're instruments of memory. Their mirrors gather light that has crossed unimaginable gulfs, turning ancient photons into present knowledge. Some of those photons began their journey when no living thing yet existed on Earth. And yet, here they arrive, falling silently into our detectors, still faithful to the message they carry. It's humbling to think of how fragile that message is. One photon, a particle smaller than imagination, can travel for billions of years without colliding with anything, never losing its story, until it meets the faint silver surface of a telescope mirror. That instant, that meeting between the oldest light and the newest mind, is science in its purest form, the universe recognizing itself. The act of seeing is not just a physical one, it is emotional, almost spiritual. When astronomers capture the faint glow of a galaxy that has travelled across half the age of the cosmos, they're doing more than gathering data. They're extending human presence across time. They're bridging what is and what was. The numbers and graphs that follow are just translations of something deeper, the feeling of connection that binds us to everything that has ever shone. Light, in its way, is patient. It carries on even when the things that created it are gone. A star may die, its atoms scattered into new forms, but its light keeps going, a final message from a vanished moment. When you see a twinkling star tonight, you're not just looking at a point of brightness. You're reading a postcard sent across time, written by a source that may no longer exist. It is both beautiful and bittersweet, this cosmic correspondence. Sometimes, when astronomers talk about what they've seen, their words turn quiet, almost reverent. They know that their work, precise and technical though it may be, deals with something fragile and sacred. Time's residue, light's long journey. One might say, we caught a galaxy from when the universe was less than 1/10 of its current age. Another might whisper, We've seen starlight from the dawn, but beneath the measurements lies awe, the recognition that they are reading the oldest stories ever written. There's a moment every observer knows well. After hours of calibration, after the night's data is recorded, there comes a pause. The screens glow faintly, the dome's slit closes, and outside the first touch of dawn begins to wash over the desert or the mountaintop. The astronomer steps out into the cold air and looks east. The sky brightens with sunlight that left our star just 8 minutes ago. A blink compared to the billions of years in the light they've been studying all night. And yet, both kinds of light, ancient and new, belong to the same flow. The universe is full of such overlapping moments, each folded gently into the next. We often imagine that our lives are brief and insignificant against such timescales, but perhaps it's the other way around. Our awareness gives meaning to these vast ages. Without us to look, the light would still travel, but there would be no one to know that it does. Every act of seeing is, in its way, an act of gratitude. The universe learning to notice itself through our eyes. In that sense, we are part of the story the light tells. The photons that reach us have travelled across the same space that gave birth to our atoms. We are built from the dust of the stars we study, the carbon in our breath, the calcium in our bones, the iron in our blood. All of it was formed in stellar furnaces and scattered by explosions that once lit up the early cosmos. When we look at the night sky, we're gazing at our own origins written across the dark. Every observation, then, is more than a scientific record. It's a reunion. The telescope is a kind of memory device, translating the universe's past into human perception. We use mirrors and sensors, but also emotion, the quiet thrill of discovery, the sense of belonging that comes from recognizing a piece of ourselves out there. Even a faint smudge of light, captured on a detector, can remind us that we are woven into the same fabric as the stars. And there's something else hidden in these glimpses: hope. The universe is not static. The light we see tonight is only part of its ongoing story. Stars continue to form, galaxies continue to evolve, and new light is always on its way. Somewhere, at this very moment, a new supernova is blooming, a black hole is forming, a planet is gathering clouds, a life form may be looking at its own sky for the first time. The light from those moments will one day reach someone, maybe us, maybe someone far in the future, and connect another link in this endless chain of seeing. So as you lie beneath the stars, remember that you are looking at more than the present. You are looking across the depths of time. You are seeing light that has journeyed for ages just to touch your eyes for a heartbeat. It's a gentle reminder that existence is long, that patience is built into the very structure of the cosmos. Every photon is a traveller, every beam of light a story still being told, and perhaps, in that realization, you can find peace, knowing that the universe, vast and ancient as it is, still finds a way to speak softly, to share its memories with anyone willing to look up and listen. Everywhere we look, the universe seems to be held in a delicate balance, an invisible harmony that keeps stars from scattering, galaxies from tearing apart, and atoms from losing their grip on one another. Yet when scientists add up all the matter and energy that can be measured, a strange truth emerges. What we see, stars, planets, dust, light, makes up only a small fraction of what exists. The rest, the vast majority, is hidden. We've already met one of these unseen players, dark matter, the silent scaffolding that holds galaxies together. But even more mysterious is its counterpart, dark energy, a force that does not pull but pushes, stretching the universe outward with a quiet, relentless pressure. Together, these two make up nearly everything. The familiar world of atoms and starlight, the universe of our senses, is only a sliver of the whole. It's a humbling realization. The cosmos that fills our eyes and instruments is, in truth, just the visible surface of a deeper structure. Like frost on a window, the light we see traces patterns on something far larger, built from forces we barely comprehend. Dark energy was discovered almost by accident. In the late 1990s, teams of astronomers studying distant supernovae expected to find that the universe's expansion was slowing down. Gravity, after all, should be pulling everything back together. But the data told a different story. The light from those ancient explosions was fainter than expected, as if the galaxies carrying them were farther away than they should have been. The universe wasn't slowing, it was speeding up. To explain this, scientists propose that space itself contains a kind of energy, evenly spread, that exerts a repulsive force. It doesn't push like wind or shove like matter, it acts everywhere, on everything, all at once. The name they gave it, dark energy, captures both its power and its mystery. We don't know what it is, only what it does. It stretches the very fabric of existence. If dark matter binds, dark energy loosens. If one shapes galaxies, the other shapes destiny. And yet, despite their opposing roles, both seem essential. Without dark matter's invisible grip, galaxies could never have formed. Without dark energy's steady pressure, the universe might have collapsed long ago into darkness. Somehow these unseen forces coordinate to keep the cosmic story unfolding. Physicists sometimes speak of a cosmic balance, though not in mystical terms, more in quiet respect for how finely tuned everything appears. The strength of gravity, the rate of expansion, the distribution of matter, all are adjusted within narrow bounds. A slight difference, and stars might never have formed, or they might have burned too quickly for life to emerge. It's as though the universe is written in a language of precise probabilities, or even chaos obeys subtle rules. This balance has inspired countless theories. Some wonder if the universe is part of a grander design, not by intention but by mathematics. A self-consistent system that could not exist any other way. Others imagine multiple universes, each with its own set of laws, where we inhabit the one that happens to allow complexity. There's even an idea, still debated, that the universe might be holographic, that everything we perceive in 3 dimensions is encoded on a vast 2-dimensional surface at its edge. In that vision, reality itself becomes an act of translation, the world unfolding from hidden information like light from a film. But even if these ideas sound abstract, they all point toward the same feeling: wonder. The more we learn about the universe, the more it seems to resemble a question rather than an answer. We find patterns, yes, but beneath them, mystery remains. Maybe that's what makes the cosmos so beautiful. Not its predictability, but its refusal to be fully explained. The galaxies we study, the light we measure, the particles we chase, all of it hints at something deeper, something softly hidden, like the low note in a symphony that you feel rather than hear. Think of gravity itself. For centuries we've described it as a force that pulls, but Einstein showed that it's really the bending of space and time around mass and energy. The sun doesn't pull Earth through space, it curves space, and Earth follows that curve. Now, quantum theory adds another layer, suggesting that even the emptiness between atoms hums with unseen activity, a restless sea of energy that may give rise to gravity itself. Each discovery adds a new verse to a song that never quite resolves. And in that endless unfolding, something profound emerges. The universe, with all its unseen elements, seems to be both stranger and more connected than we imagined. The same dark matter that sculpts galaxies also passes silently through us every second. The same dark energy that stretches space touches every atom of our bodies. We're immersed in the mystery we study. It doesn't surround us from outside. It flows through us, quietly keeping everything in motion. Perhaps that's why the night sky feels so peaceful, even when we know it's filled with invisible turmoil. The balance between light and dark, between pull and push, is not a battle, but conversation. Gravity gathers, expansion releases, matter forms, energy disperses. The universe breathes in and out, slowly over billions of years, and somewhere in that breath, life arises, fragile, curious, aware. When you stand beneath the stars and feel their calm weight, you're also feeling the subtle harmony of these unseen forces. The same physics that governs galaxies also governs you. The atoms that make your body obey the same rules that shape the clusters of the cosmos. You are, in every sense, made of the same mystery that holds everything together. So perhaps the question is not why the universe exists, but how we can exist within it with such delicate precision. Every heartbeat, every thought, every breath is a continuation of that cosmic balance. You are gravity and energy, starlight and shadow, woven together into awareness. Maybe that's the quiet answer hiding beneath all the equations. That the universe is not withholding its secrets. It's speaking softly, asking us to listen not just with our instruments, but with our sense of wonder. The mystery that holds everything together is not only out there among the stars, it's here, within you, keeping time with the rhythm of the cosmos. When we look out into the night sky, what we really see are boundaries, soft edges between what can be known and what can only be felt. Every telescope, every formula, every theory extends those boundaries a little farther, yet they always remain ahead of us, like a horizon that retreats as we walk toward it. Beyond that horizon lies the unknown, not empty but alive with potential. The universe seems vast beyond measure, but it's also astonishingly personal. The atoms that make your skin, your blood, your thoughts were all born from stars that lived and died long before the sun. The calcium in your bones was forged in the explosion of a massive star, and the iron in your blood carries the memory of that light. You are, quite literally, the universe remembering itself. Every heartbeat is a continuation of a process that began billions of years ago, the great experiment of existence. If you think about it, belonging has always been written into the fabric of things. Nothing in the universe stands alone. Stars are born in clouds of dust, nourished by the gravity of their neighbours. Planets form from what the stars release. Life arises from the chemistry those planets inherit. Even the emptiest regions of space hum quietly with invisible energy, as if refusing true solitude. The cosmos is a network of relationships, and we are one of its smallest, most conscious threads. The same laws that shape the orbits of galaxies shape your steps as you walk across a floor. The same quantum fields that allow particles to appear and vanish also make the warmth of your breath and the glow of your thoughts possible. The universe doesn't happen around you, it happens through you. You're not outside looking in, you're inside, looking out. There's comfort in realizing that. It means that even though we can't cross the cosmic distances, we don't need to. We already belong to them. The farthest galaxy and the smallest cell share the same history, the same physics, the same quiet rhythm of unfolding. The light that left a quasar billions of years ago and the spark of a neuron firing in your mind are both expressions of the same underlying harmony. And when we peer into the darkness, we are not staring into absence. We are seeing the side of the universe that does not need to glow to exist. It's easy to forget that darkness is not the opposite of light. It's the canvas upon which light is painted. Without it, brightness would have no meaning. The blackness between stars is not empty. It's filled with the same fields, the same unseen energy that once gave birth to everything luminous. Sometimes, late at night, astronomers will pause in their work and step outside the observatory dome. They stand quietly under the wide sky, eyes adjusting to the faint shimmer of the Milky Way. The wind is cold, the air thin, and the hum of equipment fades into silence. In that moment, they are not scientists or observers. They are simply participants. They feel the stillness of the mountains beneath their feet, the slow turn of Earth beneath the stars. For a breath, the line between observer and universe disappears. Belonging is not a reward we earn by understanding. It's something we've always had, waiting to be remembered. Every culture, every time has found its own way to express that truth, through myth, through song, through science. Whether we call it creation, cosmos, or consciousness, it all points to the same realization. The universe is not something we visit, it's something we are. Even black holes, those symbols of finality, are part of this belonging. Their gravity may trap light, but their influence reaches far beyond their event horizons, shaping galaxies and regulating creation itself. The same singularities that seem to end knowledge may also seed new beginnings. There's a quiet symmetry in that. The idea that every ending carries within it the possibility of continuation. When we consider our smallness against the vastness of the cosmos, it's tempting to feel insignificant. But insignificance is a misunderstanding of scale. The universe is not measuring importance, it's weaving complexity. Your existence is not an accident of dust, but a natural consequence of time, gravity, and chemistry playing their long, patient game. From that perspective, you're exactly as vast as you need to be. Maybe that's what it means to belong beyond the horizon, to recognize that there is no true separation between the known and the unknown, between science and spirit, between self and cosmos. The boundaries are soft, like the blending of colours in a dawn sky. Beyond what we can measure lies what we can feel: wonder, connection, stillness. Those are also truths, even if they can't be written in equations. Think again of that first breath of starlight, billions of years ago, when hydrogen ignited and the first stars began to burn. From that moment onward, the universe has been breathing, expanding, cooling, forming, remembering. Every generation of stars exhales its elements into the next. Every galaxy carries the echoes of its ancestors. When you breathe, you are part of that same rhythm. The carbon you exhale may one day drift upward, join the air, settle into soil, feed a leaf, return to light. In that endless circulation, the boundary between life and cosmos disappears. It's strange, isn't it? We spend our lives seeking purpose, yet purpose might be as simple as participation. To be aware, to be present, to exist as a brief expression of the universe's ongoing experiment with consciousness. You don't have to solve the mystery to be part of it. You already are the mystery, awake for a little while, watching itself unfold. And maybe, when all our questions have been asked, when the last equations have been written, and the final telescope has gone silent, what remains will not be knowledge, but belonging. Not the map of the stars, but the quiet feeling of being one of them. The same silence that lies inside a black hole also exists inside you. Not emptiness, but potential. The same gravity that holds galaxies together also holds your heart to this world. The universe is vast, but it is also intimate. It folds inward and outward at the same time, linking the infinite with the personal. Somewhere, beyond every horizon, there is always more to see, yet the most profound discoveries may already be within us, waiting for recognition. So as you lie beneath the sky tonight, let yourself feel the symmetry of it all, the stars above, the pulse within, the quiet darkness connecting both. You belong not because you understand, but because you are made of the same story, and the story is still being told, softly, endlessly, across the horizon of time. There comes a moment in every long night of watching the stars when the work stops and the silence takes over. The telescopes turn inward to rest, their mirrors cooling in the dark. The last traces of starlight fade from the screens. The astronomers step outside, stretching their tired hands, their faces lit faintly by the glow of the horizon. Above them, the sky is still vast, still full of secrets, still whispering softly in light that has travelled across the ages. And for a few breaths, no one speaks. There's nothing left to measure, only to feel. That quiet, that stillness, is the true ending and beginning of every journey into the cosmos. It's the sound of belonging. You've travelled through the story of stars and black holes, of light and darkness, of time and its endless river. You followed gravity through the depths of space and felt the patience of light crossing billions of years. And now, here at the edge of knowing, you arrive back where it all began, with breath, with silence, with a simple awareness of being part of it all. The universe is often described as expanding, but that word is too mechanical for what it truly does. It doesn't just stretch, it exhales. Galaxies drift apart like embers carried by a soft wind, each one glowing quietly in its own corner of space. And just as the universe breathes outward, you breathe inward. Every inhalation you take brings in the atoms released by ancient stars, and every exhalation sends them back. This rhythm, vast and small, cosmic and human, is the same rhythm that has been pulsing since the beginning. To exist, then, is to participate in that breath. You're made from remnants of the first fire, cooled into thought, into heartbeat, into memory. When you lift your eyes to the night, you're not a stranger looking at the stars. You're the stars remembering themselves. Every flicker in the sky is a reflection of the light that lives inside you. You and the universe are mirrors facing each other, each revealing the other's beauty. Even the dark, the emptiness between those stars belongs to you. It is not absence, it is foundation. Darkness is what allows light to shine. Silence is what allows sound to be heard. Stillness is what gives meaning to motion. When you look into that quiet, you're looking into the same mystery that once stirred hydrogen into suns. It's not something to fear or to fill, it's something to rest in. Astronomers sometimes say the universe will end not with a bang, but with a sigh. A long, slow fading as stars exhaust their fuel and galaxies drift too far apart for new ones to form. It's a melancholy image, but also a peaceful one. Even in that imagined quiet future, the rhythm of transformation continues. The last stars will cool into white embers. The last atoms will stretch thinner and thinner across space, and in that vast stillness the universe will continue to breathe, slower, softer, but never entirely still. That's because nothing in the universe truly ends. It only changes form. The death of a star becomes the birth of elements. The collapse of a galaxy feeds the formation of another. The loss of light creates room for new light to grow. Every ending, if you look closely enough, is a continuation written in a different language. And perhaps that is true for us as well. Our lives, brief as they are threads woven into that same pattern of renewal. We rise, we fade, and the matter that composes us goes on, joining clouds, rivers, soil, and someday perhaps starlight again. To know this is not to diminish life's value, but to deepen it. It means that even after your heartbeat ceases, the rhythm you carried continues, diffused through the fabric of existence. You are never erased, you are rearranged. So when you think of your place in this vastness, do not imagine yourself as small. Think of yourself as continuous. You were born from ancient explosions and cooled from cosmic dust. You are the continuation of a chain that has never been broken, one heartbeat in the long pulse of the universe. You were here when the first atoms formed, and you will be here when the last light fades. You may change form, but you never leave the story. There's a line that astronomers sometimes write in their notebooks after a long night. We watched light older than our planet arrive. They mean it literally. Photons travelling for billions of years finally reaching their instruments. But that line could also be about you. You are the receiver of ancient light, the inheritor of impossible distances. In you, the universe finds a way to see itself, to wonder about its own origins, to ask the question, what does it mean to exist? That question has no final answer, and maybe that's the beauty of it. Meaning isn't something given, it's something experienced. You create it with every moment of attention, every act of kindness, every quiet wonder beneath the stars. The universe gives you the raw materials as time, light, matter, and you give them shape through living. In that exchange, belonging becomes real. The next time you find yourself under a night sky, let your thoughts slow until you can almost hear the hush between the stars. Let yourself feel the ancient rhythm moving through you, the pulse of distant galaxies, the whisper of atoms shifting, the faint hum of your own breath joining the silence. In that moment, there is no separation between you and the cosmos. The same calm that fills the space between galaxies fills the space within your chest. You don't have to understand the entire universe to belong to it. You already do. You don't have to see beyond the horizon to be part of what lies there. The horizon is not a wall, it's an invitation. Beyond it, everything continues. Light still travels, gravity still hums, stars still burn, and life, in some form, still dreams. So as you drift tonight between waking and dreaming, remember this. The universe keeps breathing, and you breathe with it. Your heartbeat is its heartbeat. Your stillness is its stillness. Every atom in you has been elsewhere, in the heart of a star, in the curve of a nebula, in the warmth of another life. And long after you're gone, those atoms will continue their journey, carrying the memory of this moment, this breath, into whatever comes next. And so, we've reached the end of our quiet journey through darkness and light. Whether your eyes are still open or already drifting closed, know that you are part of the story that never ends. The stars that died made it possible for you to exist, and the thoughts you think now ripple softly through the same universe that once gave birth to them. Sleep peacefully, traveller. The cosmos is vast, but it's also kind. It holds you gently, the way it holds the stars, the way it holds time itself. The universe keeps breathing, and tonight it breathes through you.